If you want better blood sugar, lower inflammation, and fewer cravings, you don't need a new supplement. You need to feed the system that runs your metabolism. That system is your gut microbiome. And its favorite fuel is fiber, especially resistant starch. Protein builds your body. Fiber feeds the system that runs it. If you want more science-backed longevity strategies that actually work in real life, hit like and subscribe. And check the description for Amazon links to foundational products we mention, plus our longevity compass book. Now let's talk about why fiber keeps showing up in longevity research, and why most people still aren't eating enough of it. Fiber and resistant starch are carbohydrates you don't fully digest in the small intestine. They pass into the colon, where your gut microbes take over. Those microbes ferment fiber into short-chain fatty acids, mainly butyrate, acetate, and propionate. And those compounds act like metabolic signaling molecules. They help maintain the gut barrier, influence immune tone, and communicate with pathways that affect blood sugar, satiety, and inflammation. This is why populations that eat more fiber and whole grains consistently show lower rates of cardiometabolic disease and lower mortality. Mostly observational data, yes. But the signal is strong, dose-responsive, and biologically plausible. So let's define terms, because this is where people get lost. Fiber is an umbrella term. Some fibers are soluble and viscous, like beta-glucan in oats or psyllium. These form gels, slow digestion, blunt post-meal glucose spikes, and lower LDL cholesterol in many trials. Some fibers are insoluble, like wheat bran. They add bulk and speed transit. Less fermentation, more plumbing. Other fibers are fermentable and prebiotic, meaning microbes selectively use them to produce those beneficial short-chain fatty acids. Resistant starch is a special case. It's technically starch, but it behaves like fiber because it resists digestion. There are several types, but here are the ones you'll actually see in real life. RS1 is physically trapped starch, intact grains and legumes. RS2 is naturally resistant, like slightly green bananas or certain high amylose starches. RS3 is retrograded starch, cooked, cooled, and then eaten foods like potatoes, rice, or pasta. RS4 and RS5 exist mostly as food ingredients or special cooking chemistry. Interesting, but not required to get benefits. Now here's the longevity link. Large evidence syntheses consistently show that higher fiber intake tracks with lower all-cause mortality, lower cardiovascular disease, lower type 2 diabetes risk, and lower colorectal cancer risk. Benefits appear strongest around 25 to 29 grams per day, and often continue beyond that. And while observational data can't prove causality on its own, the consistency across populations and outcomes is hard to ignore. Where trials help is with risk factors. Fiber supplementation, especially soluble fibers, improves lipid profiles and glycemic markers in many randomized trials. Resistant starch adds another layer. In people with pre-diabetes or type 2 diabetes, resistant starch interventions show improvements in fasting or post-meal glucose in meta-analyses. The results vary by dose, type, and person. That variability matters, and we'll come back to it. Some trials also show improvements in inflammatory markers, particularly in higher risk groups. Not a miracle, but directionally positive. There's also a fascinating randomized crossover trial where resistant starch shifted microbiome patterns and metabolic phenotypes without focusing on calories. That's an important concept. This isn't just about energy. It's about signals. One engineered resistant starch-based intervention even lowered blood pressure in untreated hypertension while increasing systemic short-chain fatty acids. That doesn't mean beans replace medication. It means gut fermentation can influence real physiology. So how does this actually work? First, gut lining armor. Butyrate is a primary fuel for colon cells and is closely tied to barrier integrity and immune signaling. A healthier barrier means fewer inflammatory signals leaking into circulation. Second, cravings and fullness. Fermentation products influence satiety-related hormones and gut-brain signaling. Results in humans vary, but many people notice better appetite regulation once fiber intake is consistent. Third, glucose smoothing. Viscous fibers slow absorption. Resistant starch delays digestion and fermentation alters glucose handling downstream. Fourth, microbiome responsiveness. Short-term increases in fiber reliably change gut communities, but people respond differently. Some are fast responders. Some need more time. That's normal. Now let's talk numbers. Common intake targets are about 25 grams per day for women and 38 grams per day for men, or roughly 14 grams per 1,000 calories. Most people are nowhere near that. Fiber is literally classified as a nutrient of public health concern because of underconsumption. Translation: most people don't need a new supplement. They need a new baseline. But here's the part that makes or breaks success. You can't jump from low fiber to high fiber overnight and expect a good outcome. That's how you earn bloating and quit. So here's the longevity compass fiber ladder. Rule 1. Add about 5 grams per day for 3 to 4 days, then step up. Rule 2. Fiber without fluids is a traffic jam. Add water and mineral-rich foods. Step 1. Days 1 through 4. Add 1 anchor food per day. Oats, beans or lentils, or berries with chia or flax. Just 1. Step 2. Days 5 through 10. Add 1 resistant starch habit. Choose 1. Cooked and cooled potatoes. Cooked and cooled rice. Overnight oats. Or a slightly green banana. Tolerance varies here. Step 3. Days 11 through 14. Add diversity. 2 different plant colors per day. Legumes 3 times per week. That's it. No gut heroics required. Micro hacks that actually help. Rinse canned beans thoroughly. It removes gas-triggering residues. If you're sensitive, start lower FODMAP-ish. Oats, chia, kiwi, carrots, potatoes, and rice tend to be better tolerated. Cooling counts even if you reheat later. Some resistant starch persists. Don't stress exact grams. Consistency beats precision. Now, a quick shopping list to make this easy. Resistant starch heavy hitters: cooked and cooled potatoes, rice, or pasta. Legumes. Green bananas. Fiber all-stars for metabolic outcomes: oats and barley. Psyllium if food intake is low. Mixed whole plants for diversity. Before we finish, we need a safety section, because trust matters. If you have IBS or tend toward SIBO, rapid increases in fermentable fibers can worsen symptoms. Go slower. Choose gentler fibers first. If you have active inflammatory bowel disease, strictures, or recent GI surgery, fiber strategies should be individualized with a clinician. And if you take medications, separate viscous fiber supplements by a couple of hours as a general practice. Now let's clear a few myths. Fiber is not just for pooping. It's microbial fuel with downstream metabolic and immune effects. Not every fiber supplement guarantees microbiome diversity. They can help specific endpoints, but food variety matters. Low carb does not mean no fiber. You can stay lower carb and still do berries, chia, flax, greens, and legumes in tolerable amounts. So here's the big picture. Fiber and resistant starch don't work overnight. They work quietly, consistently, and systemically. They don't spike motivation. They stabilize physiology. Quick reminder, if this helped, like and subscribe. And check the description for Amazon links to foundational products that support gut and metabolic health, plus our longevity compass book. Now I want to hear from you. Which fiber or resistant starch food do you find easiest to stick with, and what changed once you added it? Because longevity isn't built on hacks. It's built on what you repeat.